So, what exactly is a compressor? At its very core, it's a machine designed to do one thing. It pulls in a gas, squeezes it into a much smaller space, and by doing that, it just cranks up the pressure. It's a really fundamental principle of physics, but put into mechanical action.
And when I say powerhouse, I absolutely mean it. We're not just talking about some little unit you might have in your garage. No, we are talking about massive, incredibly complex systems just like this one. Machines that can have over 1,000 horsepower, and they form the literal backbone of entire industries like petroleum and manufacturing.
So, how does a machine like this generate so much power? Well, to really understand that, we've got to look inside. We're about to take a tour of the most common type, which is the reciprocating compressor, and see how some pretty simple motions can create these immense forces. And here it is, a beautiful cutaway view. Now, I know it looks complicated, but we can actually break it down into two main sections to make it easier to understand. Over here, you've got the powertrain. Those are the parts that create all the motion. And then at the ends, you have the cylinders, and that's where the actual compressing happens. We're going to tackle each one. Okay, first up, the powertrain. The entire goal of this section, its whole reason for being, is to convert a simple spinning motion into a really powerful, perfectly straight back-and-forth movement. It all begins right here, with the crankshaft. Now, if you've ever seen the inside of a car engine, this is going to look super familiar. It's hooked up to a motor that just spins it around and around, and that unique offset shape is the absolute key to starting this whole process of turning rotation into linear motion. And really, that's its one and only job. As our source material puts it so perfectly, the crankshaft's purpose is to translate rotary motion into reciprocating linear piston motion. That back-and-forth movement is exactly where this machine gets its name, reciprocating. But you might be wondering, how does that spinning motion actually get transferred over to the parts that are doing all the work? Well, that's the job of this critical link right here, the connecting rod. It's what bridges the gap between the crankshaft's rotation and the linear action that we need. You can just think of it as a mechanical bridge. One end is going around in circles with the crankshaft, while the other end hooks up to a component called the crosshead, which, as you'll see, is designed to only move in a perfectly straight line. Now this part, the crosshead, this is just a brilliant piece of engineering. You see, the connecting rod naturally wants to wobble from side to side as it moves, but that would waste a ton of energy and probably cause a lot of damage. So the crosshead prevents this. It slides inside a perfectly machined guide, absorbing all that sideways force, and it makes sure that the piston rod moves in an absolutely perfectly straight line. That precision is what makes the whole thing efficient and durable. Okay, so we've got our perfect straight line motion down. Now let's follow it to the business end of the machine, the chamber where the gas actually gets squeezed. And here they are, the cylinder and the piston. It's pretty straightforward. The cylinder is just the chamber that holds the gas. The piston, which is attached to that piston rod we were just talking about, moves back and forth inside of it. Honestly, it's just like a bicycle pump. As the piston moves forward, the space inside that cylinder gets smaller and smaller. And that's really the core action of the whole machine. That back and forth reciprocating movement of the piston inside the fixed cylinder is what physically shrinks the volume of the gas, which forces its pressure to go way up. It's a simple concept, but it's incredibly powerful. So how does the gas get in and out of there? Well, that is the job of the valves. You can think of them as the gatekeepers. You've got an intake valve to let the gas in and an outlet or discharge valve to let the now high-pressure gas out. These things are absolutely critical for controlling the entire process. And their functions are these perfectly timed opposites. First, the intake valve opens and it lets low-pressure gas just flood the cylinder. Then it seals shut. The gas gets compressed, and then the outlet valve pops open to release that exact same gas, but now it's at an immense pressure. It's like a precisely choreographed dance. So let's put it all together and walk through the three-step cycle. First, you have intake. The piston pulls back, the intake valve opens, and low-pressure gas fills up the cylinder. Second, compression. Both valves slam shut, the piston moves forward, and it squeezes that gas. And third, delivery. The outlet valve opens, and the piston shoves the high-pressure gas out. And then the whole cycle just repeats, hundreds of times every minute. Okay, we've seen all the intricate mechanics inside, but, why go to all this trouble? Let's zoom out for a second and look at why this one machine is so incredibly vital to our daily lives. The applications are just staggering. I mean, that cycle we just described, That's what makes your refrigerator and your air conditioner work. It's a key part of gas turbines that generate power and allow for flight. It's used in your car, in countless medical devices, and it is absolutely essential to the entire petroleum and natural gas industry. And they come in literally all shapes and sizes. You have everything from the small compressors that power air tools in a workshop, all the way up to these enormous multi-stage units that are powerful enough to push natural gas through pipelines that can cross entire continents. They are truly everywhere.
And don't think this is some kind of old, obsolete technology. Not at all. Engineers are constantly refining the design to a remarkable degree. In fact, some of the most advanced versions of these compressors are considered the most efficient ones available, period. That's a real testament to over a century of nonstop innovation. So, the next time you feel that cool breeze from an AC unit or grab a cold drink from the fridge, just take a second to remember the powerful, precise dance of pistons and valves that's happening behind the scenes. It really makes you wonder, what other modern marvels in our lives just wouldn't exist without this simple, powerful act of compressing a gas?